Hello. So I've been fighting the borrow checker pretty hard recently. So yeah, last time we figured out a system where widgets have an environment and they can contain stuff like callbacks that reference it by like they're generic over it. And I built a basic implementation of a stateful widget, which basically then changes the environment to be a state thing, and then that's like how you inject new state, and thus like something like a component in usual frameworks like Vue or React or something. Um, but the limitation there was that it had only state and not the outer environment, so you couldn't pass in stuff or like couldn't call like event callbacks from outside, which is obviously needed for an actually functioning system. So yeah, so I've built like these Rust playground things to explore like the problems I'm having, because it's easier to like figure out a minimal, uh, I guess, minimal representation of the problem. And then like, so here I've just made a simple widget trait, which is just one function instead of the, I don't know, like five or something we have. And yeah, so it just has a function do widget things, which takes self, state, and environment, right? So basically I was like, okay, should be simple enough. We can just pass in mutable reference to self and environment. Now, obviously, this has a missing lifetime parameter, uh, so that doesn't compile. Oh, by the way, all of these playground uh, links here, or yeah, I've made links of them, so you can like try to see whether you can make them compile. Right, so yes, so this is where like obvious trouble begins. Um, right, so there's actually quite a simple solution to this, um, because we don't want like the obvious thing, or like if you don't think about it, like usually it's just, oh, okay, we'll add one here and then here, but uh, and I guess, right, yeah, so that's actually separate. That's a function. We can ignore it here. Right, and there's like it's not constrained by self type. Okay, so yeah, this is actually was a bit more. So by changing this to we can do this, which basically means, so now this actually compiles, because we're saying like for any lifetime A, this like needs to be a widget for that lifetime, which is like usually used for closures to add lifetime parameters to closures. Right, so this works, but like, so yeah, by the way, do V is because like if there's a for around this, then we can't just go like that. So the easiest and maybe only thing to do is like have another generic parameter, just constrain it here. Uh, so yeah, but right, so an obvious thing, like maybe the first thing to do would be to add it here, but I think that might make it either unconstrained or so let's forget that and go W state here. Right. You do need internet. Right, so not constrained. So, but yeah, like what would it even be constrained to? Because like that's the thing. What are those lifetimes? Like in theory, they should be anything. Because like the widget should be callable with like these lifetimes being anything that's longer than like the method of the widget. So this is similar to like a closure, and you can express that with for. So we can go for a. Right, so let's go back to that actually. So this is like you do it in closures, which is basically saying like for any lifetime A, this needs to be a widget with that lifetime for those two references. And that works until you actually try to use it. So here we're like, okay, let's have a button and like it has an on-click function. Now here it's not actually closure because I think I was just trying to see whether there's any difference between like a function pointer and a closure. There isn't, like in that context. But yeah, like so this one like just calls the on-click thing whenever it's the do widget things is called. Right. So and that's with this I don't know constraint. And then we get this error, which is like it's saying you must the widget must implement widget like for any two lifetimes 1 and 2. Where does it get 2 from actually? But it implements it for some specific lifetime. And yeah, so that's sort of what I've been dealing with. I think I sort of understand it. It's basically the lifetime. I'm not actually sure I fully understand it. I think I'll have to ask on the Rust users forum or something. But basically, like we're saying like this needs to be widget for any lifetime, but here at least like we're calling this function button, which requires an E as like a type E and then returns a widget of that type E. So that needs to be of a specific lifetime, and then we're passing it or returning it from the stateful callback, which there it would have to be like for any lifetime, sort of. Um, which, yeah, I think that's like causing the conflict. It might also have to do with like variance. Uh, Although I'm not fully sure how uh, variance plays into this exactly. But like the deal with variance is like that it inverses with a function. So um, yeah. Right. So next thing, I was like, right. So then I was like, okay, let's implement a thing or add a widget that isn't actually a button. So it's just an empty struct. And like if we just do that, I think it works. Right, yeah, so just warnings, but it works. Because like for the compiler knows what the concrete type is, and it's like, yeah, for whatever it implements widget. So it accepts that, but it won't accept that, right? Because still same thing. So the issue is sort of also like so actually I think that doesn't really matter at all. It doesn't make any difference really. Right, same thing. I think that's just something I was trying. Uh, right, so like there's sort of not enough information here. So actually, the button thing, I'm not 100% remembering what happens if like we call the button directly, whether you can figure it out then. Now it's missing a type because this isn't constrained. Well, no. Found. Right, yeah, of course. All right, now we need to go. Right, so this would have to be mutable reference to a mutable reference of a boolean and an E. Right, so this compiles. So it can figure it out because it can figure it out based on the closure. Well, that's actually interesting because in a later similar example, I think it didn't work. But anyway, like this isn't actually the solution because with complex components, like writing functions that return the concrete type would be really annoying and impossible in some cases. So yeah, I think it's just not viable really. I think we need to rely heavily on infiltrate for like this whole thing to work. Yeah, so yeah, so like just returning concrete types isn't really the solution. Anyway, so right, so yeah, it doesn't work with empty, but with like just I don't know why I've called this like empty bool. I guess because bool was the state, but I don't know. But obviously with a function that returns the thing is pretty much exactly the same as this. So that also works. And then I was trying to yeah, so by the way, these are just like I was trying to build different scenarios in Rust Playground, and like then I copied them to my notes, like at points where I thought like it was important. And now I've like made links for all of them so you can look at them. Should be in the video description. Right, so I was trying like I was trying to figure out like if the same problem could be replicated with just closures. So this was like some step in between there. So that works. Not exactly sure like what step in between this is, but clearly that's not a widget, and here we're not right. So here instead of a widget we have like a fn mute. Right. So then I further reduce this to like this quite simple example, which right. So interestingly, the error is different, but I think it's the same issue as uh, I guess with this or with this, right? So here the error is not general enough, and here the error is the error is actually like doesn't is doesn't make sense because it's like we expected this associated type, but we found this and it's exactly the same. But yeah, obviously there's something else that's like different. Just the error printing, it looks the same, so it's really unhelpful. Uh, right. So also might have to do with variance or something. Yeah, I don't remember exactly, but I've tried like different variants of this, I think. Right, and then I was like, okay, maybe there's another solution where the stateful widget. Alright, where you basically pass in a handler and then you call widget on it with your widget. Like the handler contains a reference to state and environment, and it also needs widget state. So I guess like if this was actually a library interface, Like that would be public and that would be public. Um, or there would be accessors maybe. Um, but anyway, so uh, right. So I thought maybe that solves the lifetime problem because like the lifetime comes from out here and like whatever the stateful widget needs to do with the widget can be done in here. So usually that's lifetime wise a bit easier, but also an error. uh, right, so does not outlive. I'm not sure, maybe like I'm not using the correct annotations, and I'm not remembering 100% like what variants of stuff I've tried. And also right now I'm thinking like maybe I need to go through all those examples more like thoroughly and take notes on like what the lifetimes should be and what the constraints are. Like I've done a lot of thinking, but like it was a bit messy maybe. So maybe I could figure it out somehow uh, in like one of the attempts I've made. Uh, right. So next thing I tried was yeah. So basically, so this is just unimplemented because I've tried to like I was like maybe a trait object, like passing a trait in a trait object as the environment solves this because like then I don't have to specify the lifetime exactly and yeah. So actually I think that's like in this example, I don't know what I've tried here exactly. That was like also something different, which maybe that's even the same thing as this one. Wait. No, not exact. I think these are out of order. Um, right. So in this one, yeah, I tried like, okay, maybe I can put this. So what I was trying was just with this and without the for. So that, but then like if you, let's see, probably the error is also like not general enough, the usual thing. Right, but like here it's saying it's required to live as long as static here. And that is because in some cases Rust for trait objects will assume like a static lifetime if you don't give it another one. And so we're back to this, which is the exact same thing as we've had before and leads to the same, yeah, not general enough, exact same issue. Right, so here it's also in this. No, this isn't with the trait object. This is back to just this struct, which is the same as a tuple, basically. This is just hanging around still. And I was, what was I trying? Right, so I like figured out that the errors are, I guess, somewhat more helpful when I used the stateful widget directly, not with the function that creates it with like an impl trait. Right here it's saying will meet its required lifetime. Right, so obviously this is like where would B come from? Right, but I think the issue really is right, yeah. So at that point, I was like, maybe it's helpful if I add a constraint here, which I can then use, but that doesn't actually help much. Yeah, it's actually really hard to, like, I've had, like, while I was writing these, I had, like, more precise thoughts about these things, but it's quite hard to, like, remember and explain those. Well, yeah. But so yeah, basically the gist of this is like that I just can't get around this issue. Um, I'll obviously have to like bang my head at this some more and like maybe ask on the Rust users forum. Uh, and yeah, but yeah, so this is what can happen in Rust sometimes. Now, like I have to say, this is like a really extreme example because usually I would say in most circumstances you can just go like, okay, we're like just returning a concrete type. Uh, but yeah, like sometimes the lifetime system can be like really hard in specific scenarios. Uh, but obviously like other languages wouldn't allow me to express any of those constraints and I would just have to use like I mean obviously I could build a widget system like they're built in other languages with all of the like inner shared mutability stuff Rust has. Not clean but possible and like there's like a bunch of different takes on that that people have done but yeah, like I want to build something where yeah, that's actually taking advantage of the whole type system. But yeah, so these are like the issues I'm running into. Yeah, so I mean, I guess let me know if you have solutions to any of these, but uh, yeah, that's where I'm stuck now. All right. Yeah, see ya.